Good morning. This is Kavi Priya, Assistant Professor EC Department. I am going to discuss about the topic phase shift keying and also binary phase shift keying. So first, phase shift keying. Phase shift keying is a digital modulation technique in which the phase of the carrier is varied based on the input at a particular time. So the carrier will undergo a phase shift based on the input signal. So the carrier will be undergoing a 0 degree phase shift or 180-degree phase shift in case of the binary phase shift keying. Whereas in case of quadrature phase shift keying, it will be undergoing a 4 phase shift based on the input signal. So PSK technique is widely used for wireless LAN. It is used in the biometric. It is used in the contactless operation along with the RFID, radio frequency ID, and it is used in the Bluetooth communication. So PSK is of two types depending on the phase of the carrier signal is being get shifted. So they are binary phase shift keying and quadrature phase shift keying. So in case of binary phase shift keying, we even call it as a two-phase PSK phase shift keying or phase reversal keying. So in this technique, a sine wave carrier takes a two-phase reversal. It can be a 0 degree or 180 degree based on the input signal. So the carrier will take a phase shift of 0 degree when the input is 0, and the carrier will take a phase shift of 180 degree when the input is 1. So the phase shift here is, in case of this binary phase shift keying, is 2. It can be a 0 or it can be a 180. And next is binary phase shift keying is a basically a double sideband suppressed carrier modulation scheme DSB and SC modulation scheme for the message being a, whereas in case here the message is being a digital signal. So it is a modulation scheme used here is double sideband suppressed carrier, whereas in case of here it is a digital signal is a input signal. And next is a quadrature phase shift keying. In quadrature phase shift keying, it is a phase shift keying technique. Here, the carrier will undergoes 4 phase reversal. Since it is a quadrature, then as the name implies, it will be undergoing a 4 phase reversal. They are 0, 90, 180 and 270. So we're going to discuss about the BPSK modulator and BPSK demodulator. So first we can see this BPSK modulator. So this is the block diagram for BPSK modulator. It consists of a balance modulator and balance modulator. So one input to the balance modulator is a carrier signal. So carrier wave generator will be generating a carrier signal, and the carrier signal is given as a one input to the balance modulator. Other input to the balance modulator is a input signal, which is nothing but it is a digital signal. So based on the input signal, the carrier wave phase will get varied and it is given as a output, which is we call it as a phase shift keying output. So the if the input signal is 1, the carrier wave will be undergoing a 180-degree phase shift. If a input signal is 0, the carrier wave will undergo a 0-degree phase shift. So balance modulator function is to change the phase of the carrier based on the input signal, and it produced the phase shift keying output. So the modulation of a BPSK is done using a balance modulator which multiplies the two signals at the input. The two signals are nothing but a input signal and the carrier signal. For a zero binary input, the phase of the carrier will be a 0 degree. So there will be a 0 degree phase change in the carrier. And for the I input is nothing but it is a binary 1. For a I input, the carrier will undergo a 180-degree phase shift. 180-degree phase change will be there in the carrier signal. So for a binary 0, it is 0-degree phase change, and for binary 1, it is a 180-degree phase change. So the output sine wave of the modulator will be a direct input. In other words, we can say it as the output of the balance modulator will be a direct input carrier signal when the input signal being transmitted is a binary 0, and there will be a 180-degree phase shift in the carrier signal when the input signal being transmitted is a binary 1. So the output of the balance modulator is a direct function of a carrier signal. It is based on the input signal. So the diagram shows the input signal and the PSA binary phase shift keying signal. So when the input is 1, there is a 180-degree phase shift is there, and whereas in case of when the input is 0, there will be a 0-degree phase shift, which is shown in the second diagram. And next is a binary phase shift keying demodulator circuit. So the diagram has a, we have a multi mixture circuit, and we have a band pass filter, and we have a detector. So the multiplier takes a two, mixture takes two input. One is a binary phase shift keying and another one is a carrier signal. The output of the mixture is given to the band pass filter and it is given to the detector circuits. So the input, two inputs are for the mixture is one is BPSK and other one is a carrier. Carrier is generated by the local oscillator circuits. So for initially, in case of mixture, we'll be giving a BPSK signal as one input and the carrier generated by the local oscillator is another input. So output is of this mixture is given to the band pass filter. So by recovering the band limited message signal with the help of the mixture circuit and band pass filter, the first stage of the demodulation is being get completed. So at the end of the band pass filter, the first stage of the demodulation is being get completed, and the baseband signal, which is band limited, is obtained, and this signal is used to regenerate the binary message bit stream. The next stage of demodulation is done at the data circuit. Here the bit clock rate is needed at the data circuit to produce the original message signal. So that's all about the phase shift keying, and we have seen what is PSK, and we have seen what are the two types of PSK, BPSK and QPSK, and we have seen what are all the generation data circuits for BPSK circuits. Thank you.